what's actually happening when a TCP connection opens? Well, what has to happen? The two endpoints, the client and server, have to get into agreement that a connection exists. Well, what information has to be exchanged in order for that to happen? Before anything happens, the client knows the server's IP address and port number, but the server doesn't know anything about the client. So the client has to send the server a message with, among other things, its IP address and port number, saying that it wants to connect to the server on its IP and port. But TCP does more than that. It also keeps track of the data that each endpoint has sent, and makes sure that the other endpoint has received it. And it makes sure the application sees that data in order, even if the underlying network reorders the packets. The way that it does this is by putting a sequence number on each packet. Each endpoint sends an acknowledgement, indicating when it's received a particular sequence number, and if a packet goes missing, the other endpoint will notice there's no acknowledgement and will retransmit it. Also, sequence numbers start out at a random number, so they're very unlikely to get confused between one connection and another. So when the client sends this first packet, it has a sequence number on it, like number 12345. And when the server sends back its first response, that has a different sequence number, like 9876. It also contains an acknowledgement, saying that the server has received packets up to but not including number 12346. And then subsequently, each packet either end sends has an acknowledgement, or ACK for short, that indicates one more than the greatest sequence number for which it knows it doesn't need anything resent. When the client sends the packet containing its request, the server acknowledges that request even before it sends the response. Then it will send the response, and the client will acknowledge each packet that's used to send that. For a realistically sized file, there will be many, many more of these before we're done. And since there will be many more of these, it's not just that the server will be sending a lot of data to the client will also be sending an ACK back to the server for each packet of that data. And because that data is going to be broken up into a lot of packets, each with its own sequence number on it, there are going to be a lot of ACKs flowing back. Even though the client isn't transmitting any application data back, all those packets will have data length 0. They'll still be telling the server how much data has been successfully received.